Use of cardiac cycle locating to minimize the influence of cardiac artifacts on esophageal pressure measurement during dynamic occlusion test. By Xuan He, Xiu-Mei Sun, Guang-Qiang Chen, Yan-Lin Yang, Zhong-Hua, Ming Zhou, Jian-Xin Zhou via respiratory care current issue. Background: the dynamic occlusion test is used to guide balloon catheter placement during esophageal pressure monitoring. We introduced a cardiac cycle locating method to attenuate the influence of cardiac artifacts on measurement. The aim was to provide a reliable analytic algorithm for the occlusion test. Methods: esophageal balloon catheters were placed in subjects receiving pressure support ventilation. During balloon position adjustment, end-expiratory occlusion was performed to induce 3 consecutive inspiratory efforts. PS and airway pressure (PA) data were collected for offline analysis. For each occluded inspiratory effort, the change in PS, delta PS, was plotted against the change in PA, delta PA, and the slope of the regression line was calculated. The delta PS/delta PA ratio was also measured with the cardiac cycle locating method and peak-to-peak method. Bland-Altman analysis was used to assess the agreement between the delta PS/delta PA ratio and the slope. We defined the occlusion test with all fitted slopes for the 3 inspiratory efforts within 0.8 to 1.2 to indicate optimal balloon position, otherwise, the position was deemed non-optimal. Using the slope as the reference, the diagnostic accuracy of the delta PS/delta PA ratio in distinguishing the optimal and the non-optimal balloon position was analyzed. Results: a total of 86 occlusion tests containing 258 inspiratory efforts were collected from 15 subjects. The median, interquartile range, slope of delta PS versus delta PA plot was 0.85, 0.76, 0.91. Bias, lower and upper limit of agreement, of delta PS/delta PA ratio measured by the cardiac cycle locating method and the peak-to-peak method was 0.02, minus 0.13 to 0.16, and 0.06, minus 0.18 to 0.31, respectively. 45, 52.3%, occlusion tests indicated optimal balloon positions. Compared to the peak-to-peak method, the cardiac cycle locating method was more specific in detecting the non-optimal position. Conclusions: the cardiac cycle locating method provided reliable and precise measurement for the occlusion test. This method can accurately detect non-optimal balloon position during catheter adjustment.